Hi, everyone. So the topic of the next panel is putting post-quantum cryptography front and center. So I think we had a great introduction from the previous panel. So now we're moving into more practical questions. My name is Arseny. I run Edge Ventures. We invest in blockchain space, so cryptography and post-quantum computing and threats is on top of our minds. So I'm looking forward to learn a lot from the discussion. So guys, why don't you introduce yourself?
I guess I'll go ahead and start since I got a microphone. My name is Danno Ferrin. I am a core engineer here at Tectonic. Previous to this, I was an Ethereum core engineer. I spent some time at the Ethereum Foundation. I spent some time at Hedera. I spent some time at Consensus. I did major contributions to Hyperledger Besu. I know I know where the bodies are buried in the Ethereum protocol. Let's just put it that way.
Hi everyone, my name is Charles Guillemet. I'm CTO at Ledger, and my background is cryptography and security. These are topics I'm interested in since I'm 12. When I got a computer, the first thing I did was to try to hack everything. It was easy at the time. And now I'm trying to secure blockchain funds at Ledger.
Hi, I'm Brian Whippo. I lead the developer relations team at the Algorand Foundation. Most of my career has been in traditional finance, managing technology projects at Morgan Stanley, and then I grabbed 2 beers and jumped into Web3, and have been there for the past couple of years, and I've really enjoyed making it my day job instead of just a hobby and a passion project, and excited to talk about how quantum intersects with blockchain.
Hi, I'm Lewis Strawbridge from Hashlock. I used to work in Web2 security in national defence in the UK, and yeah, it's quite limiting. As we all know, people who've worked in national defence wanted to jump across to blockchain and create something which would be the baseline of what security means in an emerging technology.
Okay, great. So guys, I'll be asking kind of one of you specific questions, but anyone can contribute. So to start with, we're all kind of heard about the threats. So I guess, Dan, a question to you. What are the reasons people keep delaying this?
So up until DevConnect, I think there was a lot of denial. There was a lot of disbelief that these quantum computers were coming, and that people putting up websites with brash names like Quantum Doom Clock and saying you have 3 years. They thought it was it was kind of a joke and just marketing. But it was when people like Vitalik started waking up, when some of the core Bitcoin developers started waking up, I think that started removing a lot of the denial. But once you're out of the denial, you hit a couple of other barriers that are pretty big in adopting quantum in your blockchain. The first one I discussed in my talk is key sizes. It's not an easy snap in and out. You're not getting 32 bytes in and out. You don't have key extraction from ECDSA. So you have to figure out how you're going to deal with public keys in addition to the signatures. But I think probably the bigger issue, and I've talked to at least one other blockchain here that is at the conference, at us, and a lot of the chains are in the same situation, is there's still a little bit standards lack of clarity in some of the signatures we want to use. FIPS 204, which is MLDSA, is one of the larger ones. So it's one of the ones that people don't really want to use, but they will if they have to. There's one called Falcon that people want to use, but it's got its own set of issues with floating point math. And also they're monkeying with the spec. They're going to do a inversion of the lattice to reduce load, and they still haven't shipped it. And we're still waiting on the first draft of FIPS 206, which is going to be FNDSA. And then you have the entire suite of signatures that are coming with the PQC on-ramp. One that people are particularly interested in, SkiSign, that has really small keys, really expensive computation costs, but the small keys appeal a lot, so you don't have to get some ZK snark to put things together. So there's a bit of uncertainty. If Ethereum put Falcon in today, they would have another one of those Kachak SHA3 type situations where the FIPS did one minor change, and all of a sudden you have a different spec and have to call it a different name. So that's what's causing a lot of people to hold back, is they're actually waiting for the final specs to be published and not just jumping ahead of the gun.
Yeah, as you said, there is on one side there is some uncertainty about how close the threat is. So this is what you described with denial. So this is the first part. And the second part is, technically speaking, it's not that easy to create this move. It requires some consensus on where we go, like what kind of algorithm, what kind of standard will we use. And there is no standard that is as convenient as what we already have with ECDSA. This is one part of the problem. And then, especially for blockchain, there is the problem of creating social consensus on what standard we will choose and how we will do this transition. And this is definitely something that is not easy, especially with blockchain. There is the idea of trusting the system. In Bitcoin, there is the idea of never changing the protocol. So all this question around creating this transition collide with these previous principles. This is, I think, these are the reason why this transition is definitely not easy.
Okay, great. So Brian, where should the PQC start from? Like, what is it? User wallets, nodes, APIs? What do you think?
Yeah, thanks for the question. So at Algorand, we are looking at this problem on the blockchain protocol level in 3 parts. The first part is protecting the history of the chain, and a few years back we added Falcon signatures to state proofs that are produced periodically by our nodes to protect the history of transactions on Algorand. The second part is to protect accounts, to be able to spend, and we recently added the ability to wrap an account in a stateless application that verifies a Falcon signature to be able to spend out of a traditional account. And that's live on mainnet right now, and people can start to learn about this and incorporate it into their applications. And then the third part for the protocol is really the consensus mechanism. For us, we have a unique consensus mechanism that uses a verifiable random function, and there isn't lattice-based cryptography for that now, so that's an area of ongoing research. But we do have other components of the protocol that are sort of traditionally resistant to attacks by rotating leaders and using ephemeral keys that are separate from spending keys in the consensus protocol. That gives us a little bit of comfort there, but we're focused on the nodes, and then sort of secondarily, and I can expand on this in some of the later questions, working with our developer community to upgrade their knowledge and the tools that they're using in the ecosystem around the protocol as well.
Makes sense. Now, there was a lot of talk about timing, right? So I guess, Charles, questions to you. Why teams should prioritize this now rather than later, and what this later can be?
So I think so. It's, as I mentioned, it's difficult to say how close the threat is. The thing is, like in all cases, even if we would never be able to create a quantum computer capable of breaking cryptography, I don't think it's important, because cryptography is a mathematical way to create trust. But as soon as there is a doubt, as soon as someone starts to think there might be a quantum computer, like in a 3-letter agency or in China or wherever, as soon as we have this idea, and this idea starts to be big, then there is a doubt about this trust, and then we don't have any certainties anymore about the security of the cryptography. So as soon as we are here, and I think we start to be here, as soon as we are at this point, we need to move towards post-quantum cryptography, towards the point where we are rebuilding this trust. And as I mentioned, there is a lot of challenges, because we need to agree on what will be the algorithm that we are going to use. Thankfully, we had the NIST that standardized a couple of them, but that's not enough. Then how do you use them? What are the formatting of the transaction and all of this? And how do you integrate this in the blockchain? Because you will have bigger transaction. When you see the discussion that you have on the Bitcoin community, where they really are more in favor of using hash-based signature, where in Ethereum they are more in favor favor of using like lattice-based signatures. So already you can see that it's difficult to reach this consensus. So I think we must have this discussion as soon as possible so that we settle on where we want to go and create this path for the transition. And at Ledger, what we are doing. So as you probably know, we are manufacturing a wallet for retail, but also we have a security solution for enterprise where we are leveraging HSM and this kind of thing. And what we have built is an operating system with a set of cryptographic primitives, and then it's up to the application to leverage these primitives to implement like the signatures and so on. So what we are going to do it consists in adding like new cryptographic primitives, allowing you to post-quantum sign your transaction in the future. But the thing is, like today, like almost no blockchain use like post-quantum crypto. So this is where we are. And going to like the specifics on this, we are also using like secure hardware, smart card technology. This is the technology that you can find in your passport and in your banking cards, or HSM technology that the banking world are using. And these hardware are specifically designed for security, especially like in a context where an attacker has a physical access and this kind of tamper-proof resistance. But they were designed to support ECDSA, RSA, still DES. Like you might be surprised that in the banking system we are still using triple DES, but they are not like specialized into post-quantum cryptography support. It's possible to build them fully in software, but you don't leverage the hardware resistance that is provided by the smart card technology and the HSM. So this is where we are. The next generation of the smart cards and HSM will provide the hardware primitives allowing to build those primitives. So for next generation devices, next generation HSM, we will have the acceleration on the hardware side. And in the meantime, what we can do is to implement them on the software, fully software on the smart card and HSM. But there are plenty of constraints, especially you mentioned Falcon. Like if you use like floating point arithmetic, this is definitely not very suitable for this kind of hardware architecture. So this is where we are.
Makes sense. So, Lewis, what does a good kind of crypto inventory look like for a blockchain project?
Yeah, so I think one of the main things is designing with modularity in mind. So yeah, essentially making your contracts upgradable and at a rate which can keep up with the level of quantum research. Essentially, if we say chain analysis, say 5 to 15 years until we can break quantum algorithms. But, essentially we don't really know what the post-quantum world is still going to look like. So I think that uncertainty makes it hard. But yeah, so if I was to be invested in a project now, I'd definitely be looking at, is the project modular, and is the team flexible? Is their mindset flexible to change?
Makes sense. So Brian, and the next question to you. What is the priority essentially, right? So what is the first system that teams should migrate?
Yeah, I think the point that you made about modular and upgradable applications is really key. That's an approach that we're taking around the accounts that we have on the chain. We have an account-based model, so we need to protect that, and we've created a way to verify these post-quantum algorithms in our virtual machine. And now we are working very closely with wallet developers and application developers to understand this and start to build it into to their tooling and their workflows and so forth. Because the educational element here of moving the entire community is an incredibly heavy lift. So we wanted to make these capabilities available in our chain as quickly as possible, and then start the journey of educating folks and all the experimentation that needs to happen to find the rough edges on these implementations and find where they interrupt the user experience and the performance of the network and so on and so forth. So I think, to the the question you asked earlier about like, when should we start is yesterday is the answer, right? Because there's so much learning to do. And the Web3 industry has just spent basically a decade and a half learning on classical cryptography, and there's still problems that exist, right? So we really need to accelerate this process for PQC.
So as usual, the people, not the tech, is a problem. Then a next question to you. So how should teams handle the hybrid approaches during the transition?
So hybrid encryption within post-quantum cryptography circles usually means using both a classical and a post-quantum algorithm. One example is X-Wing. It's a replacement for ECDSA, where you would do your key agreement both with an ECDSA algorithm, and in the case of X-Wing, you would use MLChem. So the theory that goes on with there and why that's useful in key agreement is if over time one or the other algorithms gets cracked, then you still have a backup. So when it comes to security in a blockchain system, having your account backed up by multiple keys is really a belt and suspender type situation where you can make sure that, if the quantum computer does show up, it's like, great, they've only cracked half the key. They need 2 keys to unlock this. So it provides multiple optionality. There's also going to be models where people are using just 1 key, and in your system, you're going to still have a mix of ECDSA and post-quantum accounts. That's going to be kind of a harder type of a hybrid situation to deal with. It's not your traditional post-quantum hybrid, in that you're going to need to have those accounts interact together with each other. But one day there's going to be, the 2030, the 2035 day that's going to shut down your use of the elliptic key. You need to make sure that people who are using the classical cryptography know that they're going to be locked out, and give them incentives. You could do things like you could start charging more gas for them using them. And the way they get locked out is eventually it gets, asymptotically expensive. They can still use it, but then they have to pay more and more, and then they realize what's going on, so they head for the exit doors quicker. But I think hybrid cryptography is going to be somewhat of the world we're looking at in the next few years, as far as using both a classical and a post-quantum, because the speed and size advantages of elliptical are just too hard to give up until you pry it from our cold dead hands, and that's going to happen.
Yeah, on one side, it's a safe a safe approach to the transition, so that you have like more guarantees that even if there is a quantum computer or the choice of the post-quantum crypto is not safe in the future, we are still safe. So this is definitely the safer approach. But at the same time, on the other hand, it creates a more difficult transition. So this is also something that needs to be taken into account. And for this reason, I'm not sure that I would push towards that direction.
Okay. So, Charles, you're dealing with consumer, you're dealing with businesses. What about regulators and auditors? Like, what kind of evidence should they be looking for that this is like post-quantum safe?
So for now, the regulators are not really like mandating anything in this area. So we have the NIST that is like mandating the transition towards post-quantum crypto by 2035, and we could think like 2035 is in a long time, but transitioning every single cryptographic system that we have in the world to PQC in 9 years is already like very, very difficult, very challenging, and I'm not sure we will succeed. I hope so, but that's quite a challenge to be honest. And I think we're going to see like the banking industry, the finance industry, the defense industry that will move towards PQC, and they will set the standards because they have like strong compliance department, and as soon as you want to work with them, they will mandate their clients, their partners to use these standards. So I think this is that this will be these actors that will create the standard and the framework rather than the regulators. I think the regulator will have a look at what's going on and adjust the recommendation according to this.
Yeah, basically setting best precedents and then following from there. So this next question to you: what are the common integration mistakes, PCQ integration mistakes that you see?
Yeah, so I think, as we're in blockchain, we can always just think it's a Web3 problem, but we know for a fact that, it's going to change the whole security landscape. So you need to consider, the Web2 side as well. So yeah, I think definitely consider the whole attack surface. It's not just a blockchain native problem. Also, yeah, I think some people mentioned earlier about the harvest now, crypt later threat. So, I mean, in this transition period, yeah, it's going to be incredibly important that you're preventing any data breaches from your organization of sensitive data, because, yeah, as we know, those files are going to be able to be decrypted later. We know that for a fact. So, yeah, during this time, definitely consider your Web2 security as well throughout this process. I think that's often overlooked.
Okay, Danno. How do you see the priorities essentially? Like this post-quantum being like front center, the priority. What does it actually mean for organizations?
So for an organization to have post-quantum front and center, you got to realize organizations are made up of people. And if quantum is front and center, I can take literally anyone in that organization, the person, any person in a booth at a trade show, anybody who's handling any of the smaller details, the accountant that's handling your finances, and they would be able to know that they have a post-quantum policy and a post-quantum approach. Now, they may not be able to articulate the details, but those people then would be able to point you to say, oh, that's in this department, this person. And if you're in that department and they're doing the post-quantum cryptography transition in there, and you're not the one doing it, you know exactly the person to talk to get to it. So if it's front and center, anyone can know how to get to the person working on it and what the problems are and address the problems. If you walk into an organization and you say post-quantum cryptography, and they're like, is that like postmodern art? That's when you have a center and it's not front and center in your organization. They need to understand the quantum threat. Even if they just hear quantum and they don't know about the post in the cryptography, they say, oh yeah, quantum, that's something R&D is working on. You might want to go talk to Bob. So when everyone knows it's being worked on and the closer you are to it, the greater detail you can articulate what's going on. That's the sign that post-quantum cryptography is front and center.
So back to coaching people. Hopefully we're doing a bit of that. So Brian, question to you. You work with developers, and as an L1, there's like a lot of focus on that. So what needs to change in terms of dev tooling in order to make PQC like a baseline?
We basically need a whole new generation of developer tools, right? We've spent the last years making it as easy as possible for people to build and integrating with services and tools and libraries across the broader blockchain ecosystem, with interoperability, et cetera, et cetera. We basically have to go down to the basement and replace the foundation of the house for all of these tools. So there's work to do on libraries. There's work to do on networking, quite frankly, because of the amount of data that needs to be exchanged. And additionally, I will say as a DevRel, a lot of documentation, right? And educational materials to upskill people in this arena. And we've just started scratching the surface of this by providing, CLI tools and the first iteration of libraries for wallets to use to apply Falcon signatures instead of, elliptic curve signatures and so forth. But it's going to be a long journey. And I think it's incumbent on every developer in this ecosystem to be asking about this, right? To know where to go and be asking the question. And if you don't get a satisfactory answer, right, follow up. And also, if you don't get a satisfactory answer, maybe think about, is this the technology I want to be working with, or is this the organization I want to be working with? So are they thinking about these things? So we've been at the main conference this week, and people coming up to us at the booth have been asking about quantum in really substantive ways. So that's exciting. And but I think it's fair to say there's a lot of work ahead of us collectively to upgrade. Everywhere an elliptic curve signature is happening, everywhere encryption is happening, and to question, does this need to be upgraded, and then start prioritizing. That's with my project manager hat on. So it's going to be a long journey.
Makes sense, Lewis. So. There's a lot of talk, but what are the signs, like direct or indirect signs, that organization is actually PQC ready?
Yes, I think first and foremost, they're implementing one of the NIST digital signature algorithms, which we've talked about. So yeah, currently I think they have 4, right? But yeah, this could be more developed over time. So yeah, definitely implemented the algorithms, also designing with modularity in mind. So yeah, that should be first and foremost. I'd want to be seeing that, and then yeah, also if I was, if I was asking, I was a VC. I know there's some VCs here tonight, and I asked a project, okay, so what are you doing? What's your implementation plan to move across to be quantum secure? If they don't have an answer for you, which is clear, I wouldn't be investing. So that's all I'll say on that.
Okay, so to wrap up, Charles, back to the timing question. Essentially, what are the successful PQC migration look like now, this year, in 6 months, in 2 years? So what's going to change?
I feel you are quite optimistic. In 6 months, I don't think a lot of things will happen. Unfortunately, if we consider like the next 2 years, I would like us, like as an industry, to at least agree on the plan, because today it's not even the case. Like people are discussing about this topic. So first of all, it's not yet like the main topics. Like people are more talking about AI than PQC, which is a completely different topic, obviously. So first of all, I'd like this topic to be part of the discussion, and then that we would be able to reach a consensus on where we want to go, at least for the main blockchain, so that we can create the plan and create the transition, because it will take time. So for me, I'm not that optimistic. I don't think like Bitcoin or Ethereum will move towards PQC in the next 2 years. But at least if in the next 2 years we are able to reach a consensus on where we want to go and how we want to tackle this, I think that would be already a success. Especially when I see like discussion around the idea that some addresses wouldn't be vulnerable because the public key is not revealed on chain. I feel this argument is very weak. Like the public key are supposed to be public, so the security of the system shouldn't rely on the fact that the public key has not been revealed. It doesn't make sense. So we are still around this discussion where a little bit of nonsense, and I'd like this to progress, and I feel that at least in the Ethereum community, like in the past few weeks, months, it's progressing. So it makes me a little bit optimistic.
Cool. So we have a few minutes, I hope. Any questions from the audience?
Yeah, hi, I'm Peter. Hello. Yeah, for Charles, we often hear that Bitcoin is sort of like the immovable object of Web3, right? Getting a quantum safe sort of soft fork for Bitcoin could take maybe a decade. We don't know. Hopefully not. It being $1 trillion asset, I don't know if it still is today. The prices are dropping a lot this week. But I imagine for your business, it's sort of important to be able to protect this asset. So is Ledger maybe exploring sort of a future where the device can act as a prover rather than just a signer? Instead of waiting for the L1, could the Ledger generate sort of a ZK-proof shield or something like that to make the asset quantum secure, even if the L1 decides not to, or isn't just simply not fast enough in migrating to post-quantum?
Thank you for the question. First of all, if Bitcoin doesn't do anything, there is nothing we can do to secure Bitcoin. So unfortunately, we don't have this power. To your point about using the device with ZK, so first of all, when you are creating proof, most of the time you don't really need like a secure enclave, because the proof itself can be trusted. So you don't need like integrity of the code execution guarantees, because it's built in by the math for ZK. So this is not something we explored because it's not really necessary. Secondly, creating a proof, ZK proof, is often very costly in terms of power and so so on. And Ledger device has a limited like a computing capacity, and it's on purpose. Like it has only one mission, is to like do security, like sign messages, encrypt stuff, and not much more than this. However, there was something that we explored. This is the opposite. The idea is to because the device is disconnected from the internet and there's no way to know if the data that is coming inside the device is legitimate. And one idea is to like create off-device proof of anything that the device can consume and trust. So this pattern could be quite interesting. Today, the pattern that we are using is a little bit different. It's more trusted. As soon as we want to have, like, for instance, a trusted name on device, if you want to have your ENS on the device, Ledger is signing a message saying like this address belongs to like this ENS name, and in a trusted way, Ledger trusted way, you can see on device that this is the case. And this pattern could be moved to like a zero knowledge proof pattern and consumed by the device, and removing the need for Ledger to be a trusted entity. So this is something that we explored, but it doesn't really solve the Bitcoin problem that you mentioned at the beginning. Sorry.
Okay. One more? No time. Okay, guys. Thank you.
Thank you.